Good evening, all. We're trying to show that this fraction with an incredibly large numerator reduces down to just a natural number, a positive integer. Now, just to be clear on the notation, I like this notation a lot. 15 over 4 does not reduce. It's not a natural number, so we could put is not a member, okay, of the natural numbers. Again, just a way of describing things. I just kind of like this symbolic character of it. Now, what about 12 over 4? Okay, well, 12 over 4 is equal to 3. Which is a member of the natural numbers or the positive integers, right? So that's what we mean by this, okay? Now, another way to look at this is in terms of congruences. This side right here, this right-hand side just means this number minus 0 is divisible by 151, which is exactly, what the beginning statement says, okay? Now, notice we caught a little bit of a break here. A lot of you are going to anticipate what's happening here. 151 is easily established to be a prime number. It's prime. Now, it's easy to check this for primality. All you have to do is check all the primes up to, I think, 11. 13 squared is 169, which is bigger than 151. So you have to check divisibility by 2, 3, 5, 7, and 11. And none of those primes divide 151, ergo it's a prime. Okay? Now let's get down to business here. Now we're going to try to do this sort of, I guess, step by step. You guys, this 151 prime in this statement should remind you very much of Wilson's theorem. Now notice that if we rewrite this as, why is this true? That's what we want to talk about. Notice that 150 times 149 factorial is just Wilson's theorem disguised a little bit, is congruent to -1. Now I'll save the writing time here, right? But this is a statement, but it's mod 151. But notice this is just a statement of Wilson's theorem because this would be 150 factorial, which would be p minus 1 factorial, right? So what happens right here, though, is that 150 is actually congruent to -1. You see, 150 is congruent to -1. All right? And so you can see how this works out, why that's true, right? Multiply through by the minus sign, and we get this statement right here. So you see, this statement is just almost an immediate corollary of Wilson's theorem. And this is a statement of Wilson's theorem if you just recognize this as p minus 1 factorial or 151 minus 1 in this case, okay? So we know that this is true, okay? We know that this is true, just a corollary of Wilson's theorem. Now, what we're trying to show is that this is true, okay? Well, notice that we can write this statement right here. Let me just come here like this. Okay, we can rewrite this as 149 in much the way we just did on the previous thing here. So we can write this as 149 times 148. In fact, 148 factorial. Yeah, sorry. Let's look at the wrong spot. So we can rewrite this like this, right? And again, I'm not writing, it's understood we're doing mod 151, but notice that this is congruent to -2. So this is -2 times 148 factorial. Okay, is congruent to 1. But notice, see, that's not, it doesn't seem like that's what we're looking for, right? We have this, but notice that if you multiply through by the minus sign, you get, and then bring it to the other side, you'll get 2 times 148 factorial. Okay. Now that would make this a -1, but if we bring it to the other side, we will get +1 congruent to 0, right? Okay, folks, and if you see, that's exactly what we were trying to prove up here, right? Kind of neat. All right, so that's why I like working with congruences, modular arithmetic. It's just a little bit easier, in my humble opinion. But anyway, this proves it right here. We are done. I don't know if that merits a QED or not. But anyway, that takes care of business, folks. And I hope you enjoyed that one. I liked it a lot.